Sir Isaac Newton was the first person to clearly explain the relationship among forces, mass, and motion. These are his 3 laws.
Newton's first law, the law of inertia. Provided there is no net force, a body at rest remains at rest, and a body in motion remains in motion with a constant velocity. In the video, this law was exhibited through an automobile braking to a stop. The locking wheels on the road provide the force that changes the state of motion of the car. The body in the car, however, does not have this opposing force. The body will remain in motion with the same velocity and same direction. There is a force, however, that will eventually act upon the body, bringing it to a safe, abrupt stop: the seatbelt.
These next few clips demonstrate Newton's second law, the law of acceleration. This states that the acceleration of an object is directly proportional to the net force acting on it, and inversely proportional to its mass. The direction of the acceleration is in the direction of the net force. This law is divided into 2 parts. First, the acceleration is proportional to the net force acting on it. The first clip demonstrates the scooter at only half power or possible force. The second clip showed the scooter accelerating at a faster rate because more force was applied, considering the weight remained constant throughout both trials, and the force increased. The equation sigma force over mass equals acceleration. Acceleration increased when there was more force provided. The second law states the acceleration of an object is inversely proportional to the mass. We demonstrated this by adding another person to the scooter to add mass. Moving at full power, the scooter with 2 people on it accelerated slower than the scooter with 1 person on it. If the force remains the same and the mass increases, then using the formula sigma force over mass equals acceleration, one may calculate that acceleration will be less.
In the previous clip, Newton's 3rd law was exhibited. Newton's 3rd law is the law of interactions, which is whenever an object exerts a force on a second object, the second exerts an equal and opposite force on the first. We demonstrated this by throwing a volleyball at Mike's hand. The impact of the ball causes him pain. This is because when the hand and the ball come in contact, each exerted an opposite force on each other.